Neutralization. What is neutralization? Acid reacts with base to give salt and water. This reaction you have been studying from lower classes and you must be knowing this is known as neutralization process. And what we are about to talk is, what do you think? Energy is released or absorbed during the process? The temperature of the container in which the reaction is happening increases or it cools down. I think this is something you might not have thought about. So, today we are going to discuss that and how much energy is absorbed or emitted during a neutralization process. So, that is what the topic is. Topic is enthalpy of neutralization or heat of neutralization. The energy release, yes, the energy is released because it's an exothermic process. It's an exothermic process. Neutralization is an exothermic process. Heat is released. So, definitely the temperature of the container is going to increase. All right. So, how much? How much heat is released during a neutralization process? The amount of heat released depends on which kind of acid or base has been taken. If you take a strong acid with a strong base, if you take a strong acid with a strong base and do the neutralization, then the energy released is always a fixed value, and that fixed value is 57.1 kilojoule per mole. Alright, when 1 gram equivalent of acid reacts with 1 gram equivalent of base and both are strong, both are strong, strong acid and strong base, when they react with 1 gram equivalent, then the amount of energy released is a fixed value, and that is 57.1 kilojoule per mole or minus 13.7 kilocalorie per mole or per equivalent, you can say like that. So, this is a fixed value, just remember this, right. So, this is a fixed value minus 57.1. It does not matter which acid or which base you have taken, just remember both have to be strong. A strong acid, a strong base, fixed energy release, that is 57.1 kilojoule per mole. What happens if one of that is weak? You can understand weak acid means, weak acid or weak base means they do not ionize much. So, some portion of energy released during neutralization is used in their ionization. Yes, it is what happened. So, during neutralization of a weak acid, weak base, the amount of energy released is slightly lesser than 57.1 kilojoule per mole. For example, if you do a neutralization process of a strong acid HCl with NaOH, you do strong acid HBr with NaOH, you do neutralization of H2SO4 with KOH, all are strong acid based neutralization. In all cases, you will get 57.1 kilojoule per mole of energy release, right. But if one of that is weak, for example, if I take acetic acid with NaOH, then the energy release amount will not be 57.1, it will be slightly lesser than that. For example, if I say enthalpy of neutralization of acetic acid with NaOH is 57.1 kilojoule per mole, then I would like to correct that. The energy released for acetic acid and NaOH is 50 kilojoule per equivalent. That means 7 kilojoule is used in the neutralization of weak acid, and that is ionization energy of weak acid, right. So, if we take weak acid or weak base, the amount of energy released is always lesser than the standard value, that is 57 kilojoule per mole or per equivalent. So, just remember, if a strong acid is strong base 57.1, if one is weak lesser than 57.1, if both are weak even lesser, even more less energy will be released. So, this is what enthalpy of neutralization is all about. Next is enthalpy of a solution. What happens in a solution? Solution, two steps are there. Let's take, you are taking electrolyte AB, you are dissolving that, right? So two steps will be there. One is AB will break down, AB will break down into A plus B minus, and energy absorbed in this process is delta H lattice. Next, A plus and B minus will undergo hydration or solvation. So energy or energy change in this process is known as enthalpy of hydration, and they will form A plus aqueous and B minus aqueous. So you can see two steps the phenomena is happening. So from AB to A plus aqueous and B minus aqueous, this is known as enthalpy of solution. So delta H solution. So delta H solution is equals to enthalpy of lattice, delta H lattice, and delta H hydration. So that is enthalpy of solution. Alright. And next is another enthalpy value, and that is enthalpy of dilution. So what is dilution? Dilution is addition of solvent. So in a specific amount of solute, at specific amount of solvent combines, that phenomena is known as dilution enthalpy or enthalpy of solvation. So you have it here, HCl gas plus 25 aqueous or 25 moles of water, that adds up to give HCl dot 25 HQ AQ, that is 25 moles of solvent gets attached to HCl. So energy release in this process is minus 72.03. So this is known as enthalpy of dilution of HCl, right? Here we have taken 40 AQ, that means 40 moles of water getting attached. So energy release is minus 72.79. More the number of solvent molecules getting interacted with solute, higher will be dilution. So more, so you keep adding water or a solvent, enthalpy of dilution keeps on increasing. So that is it for now.